Welcome everyone to the Western Museum of Flight. I'm Cindy Maka, the director. From the Gulf of Tonkin to the Mediterranean, our speaker today has demonstrated the mettle of our venerable A-4 in promoting and defending freedom across the globe. Ladies and gentlemen, now we are going to learn about this venerable aircraft from someone who knows it inside and out. Captain Kirschke, front and center.
Thank you, Cindy. Okay. I always like this picture. I took this over in Westpac on a training mission. Good morning. Okay. There we go. Overview of the presentation, my introduction to the A-4, a little bit of history, some design features, operational features, personal experiences, and then we'll go to the questions. I was in the Marine Corps right after college. A draft got after me, and I ended up training as an infantry platoon commander in Quantico, Virginia. And during that time, I thought, well, maybe there's a better way of making a living rather than going over there in the rice paddies. And I signed up for pilot training. And that could have gotten helicopters or fixed wings. And I really didn't know too much about aviation. And I did see one promotional movie about the F-4. I thought, that's great, man, it looked pretty cool. I went off to an Air Force pilot training school. And by the way, Roy Martin and I were roommates there. We were in the same class. And everybody in the Air Force thought this F-4 was the greatest thing there ever was. And so I was, hey, I got a chance of getting that as an assignment after pilot training. Well, my orders came down, and it was for an A-4. Now, I didn't even know what an A-4 looked like. I mean, that's how naive I was on this. And I was a little dejected, but I knew I was getting a fighter, and a lot of guys in the Air Force were not. One of the pilots, the instructor pilots there, had just returned from Southeast Asia flying F-105s. He pulled me aside and said, Doug, you got the better deal. Okay. So then I went off to the East Coast and started training in the A-4. And we were right next to an F-4 training squadron. And I had to go for another 3 months to get my wings, my Navy wings, bring me up to speed. And then I was in another 3-month program to set me up to go over to Vietnam. While I was there, I kind of observed the difference between this F-4 that I wanted and this A-4 that I got. And one, there's a heck of a size difference. And they're very complex airplanes, the F-4. And we had, in the A-4 community, because they're so dirt simple, we had a lot of flying time. They didn't. But it did tell me one thing. Put enough engine on a brick, and you can make it fly. All right, 1952. Navy decided, hey, we have enough of these big airplanes. Let's get a light attack jet, carrier-based, a 2,000-pound bomb load, and it had to be conventional or nuclear, tactical nuclear, top speed of at least 500 knots, maximum takeoff weight. They wanted it small, 30,000 pounds. By the way, a takeoff weight in an F-4 is somewhere around 50,000 pounds. And it must not exceed $1 million a copy. Over at Doughlas Aircraft, there's a man named Ed Heinemann. And you mentioned Ed Heinemann in the A-4 community, and everybody knows who he was. He was really against these big airplanes, and he said, all right, we're going to build or design an airplane here that's going to be small, simple. And he was merciless in his attention to details. Everything he could do to minimize weight, he did it. A short wingspan, so he didn't have to have folding wings. I mean, this thing is 27.5 feet wingspan. My Bonanza's 34 feet, I think. So it's a pretty significant idea just to get, and I'll have other pictures of the wing here later. simplify every component to the bare minimum, and that is truly done. And every unnecessary redundancy, it has to be really examined. 2 years later, the first flight, 1954, they delivered up on all promises, even with that first flight. Weighed in 7,900 pounds, 270 pounds lighter than specified. Top speed, 90 knots faster. The first airplane, first 500 airplanes that came off the line was $860,000, which was less than $1 million. The flight test program, they had some design improvements, which I'll get into. And for a short time, it did set a world speed record for a 500-kilometer closed course of 695, and then the F-100, I think it came along with its afterburner and broke that record. Production, just quickly, there was a 25-year production run on the A-4, produced 2960. There was foreign sales to 9 different countries. I can go through them. Israel was a big, they put them really to good use. Right now, today, still flying, there's 12 military. I think they're down in South America somewhere. And then there's 26 still flying in contract work. They go do contract work to the Air Force and the Navy for air combat maneuvering. They're a very small, agile, simple, cheap airplane to run. And there's 5 of them that are privately owned that are flying. A couple other things. The Blue Angels used the A-4 for 12 years. And they could really do a tight show with it. Okay, this is just a schematic view of the airplane. The idea was keep it small and simple. And it was small. That's the first thing that I noticed about it. And it's very tight. You see the one pilot, there's a, I'll get into it, there was a fuel tank right behind it, and then the engine. The cockpit, that was small. Let me tell you, it was small. You had to organize your charts and anything you thought you were going to need for the flight before you got in that cockpit, and you had to put it in a way that you could get to it. There's no way you could unfold a chart or anything like that once you had that canopy down. It was pretty tight in there. This is a shot of the wing. For keep costs down and the size, one piece manufactured, in other words, one part of the manufacturing facilities fabricated the entire wing, and then they would made it to the fuselage. The fuselage was, again, basic, simple. The semi-monocoque, I think I can say that word, construction, is proven to that construction, very rigid, spreading the loads among all the structures and the skin, and there's no single component or single point of failure in there. The airplane is designed for ease of maintenance, and if you look out on the A4 there or here, you see that there's a seam in the fuselage just towards the back end of the wing. There's an access hole up there in the back of the wing into the fuselage. There's some quick disconnects on the control cable, quick disconnect fittings on the hydraulic lines, and then there's a quick disconnect on the clamp for the tailpipe, and the engine stays with the front section, and then unbolt the 2 sections, and you can and then put a little trailer underneath the tail, and you can split this thing in 2, and you get total access to the engine to remove it or whatever you needed to do. There's a picture of the original engine, the J65. The first one was 7,700 pounds of thrust. This was the biggest improvement I saw in the A4 over the time frames. It started off with this relatively small engine now, 7,700 pounds of thrust. And then Pratt & Whitney came up with the J52 series, started in about 8,500 pounds, and 9,300, they upped it a little bit. And those were I flew a lot of those airplanes, and they were pretty good. And right towards the last, when I was, before I got out, The A4M and the A4N for Israel came out with this P408 engine with the 11,000 pound thrust engine. Now, the empty weight of this airplane at that time was about 12,000 pounds. So you put a little bit of fuel in there and you had one heck of a performing airplane. Fuel system, dirt simple. You can see there's a red arrow pointing to the back of the cockpit. There's a small rubber self-sealing fuel tank back there. That's your engine feed pump, or feed tank. The wing is all wet. In other words, the entire wing structure is filled with fuel. But if you take a hit in the wing, it's not self-sealing. And then there's 3 wing stations down. You can look out on the A4 out there, and you can put drop tanks on there, and you can pressurize the drop tanks. No pumps or anything. You just flip a switch, use complete air pressure, and it'll pump the fuel up into the wing tank. And if you took a hit, you could also, and you emptying fuel, well, you can one switch and you'd bypass the drop tanks going into the wing, and it would go right up into the feed tank. Electrical system, again, keep the weight down, keep it simple. There was one engine-driven generator. There was no battery in there. There was no electrical starter motor. And they had a probe in there with an air turbine that to put compressed air through it, and that would spin it, and then it would get the engine going, and you had to hook an external power up to the airplane for the igniters to get the jet engine going. And then once you got it going, you disconnected all that, and so that was another weight-saving device. There is a standby generator there's a little compartment over on the right side of the fuselage. It's stowed up in there. It's not only about that big. And it had, the pilot could release that, and I'll show you how later, and flop into the airstream, and a little prop on there, and the variable pitch, and it would keep the right speed for the frequency that was needed for the aircraft. Flight controls. Cable to all the flight controls. Normal, what you see in aircraft at the time. This is long before fly-by-wire and all that good stuff. But in parallel, they had hydraulic systems that would hook into the control systems, the control cables, and assist the overcoming the pressures, because you get this thing going at high speed and there's a lot of pressure in there. And so you had to have the hydraulic controls. Now, hydraulic control is you move the stick, and that sends the hydraulic fluid, the piston moves, and there's no resistance to it. In other words, if you could move the stick and you couldn't feel it. So they had to put artificial feel in there, and they got bungees in the systems, bungee springs, such that whenever you deflect it, the further you deflect it, the more resistance you would get. So that would keep the pilot from just doing something stupid. The flying tail was just an electric motor back there that the whole tail would move. That was your horizontal trim. In the event of a hydraulic failure, this is important, you could disconnect. You didn't want to be dragging these cylinders along with the control systems. Another lever, and I'll show you that, where you could disconnect the flight controls from the hydraulic system, and you're on manual control. And there was talk about it a little bit, there's a trim tab out on the aileron to aerodynamic trim tab, and to assist in trimming the airplane and flying it manually. Now, I'm here to tell you, the first time I did that on a test flight, to disconnect it and check the rate of roll for the trim tab, and it's irreversible. You disconnect and you're disconnected, and that's it. And so you would set yourself up for about a 10-mile straight in, pointed it at the field and disconnected it. And the first time I did it, I thought, this thing didn't work. And it took two hands, and I disconnected at about 200 knots and accelerated, I think, 250, and the idea was to take your hands off and check the rate of roll. I had, you know, it was really something to hang on to this thing. But you do a straight-in landing, and it was all pretty good. This is this trim tab, and the whole idea there is that when mechanically, when you had the hydraulics in there, it doesn't matter where that little trim tab was. But when you wanted it, if you had to disconnect it, you didn't want it so far out of trim that all of a sudden the airplane's going to start rolling on you. So the idea was to have that deflection of the trim tab in sync with the hydraulic trim, and that was part of that flight test I was mentioning. Landing gear, this is what I really liked, was it was hydraulically actuated, and there was up locks to hold the landing gear up, and they were hydraulics, but the landing gear retracted down, or extended down and retracted forward. So to get the gear down in the event of a hydraulic failure, there was again a simple way of disconnecting those up locks just with another little cable, and the gear would come down, and the airstream would help it get it down and locked, and worked pretty good. Another feature it has is these high lift aerodynamic wing slats. Now you can see a picture here, and you can go out and look at the airplane out there, and at the leading edges of the wings, these are not controlled by any mechanical means. They're just gravity when the airplane's not flying, like you see them there. And as you pick up speed, while they go back up on rollers. And as you're coming in for a landing, as you slow down and start increasing the angle of attack, they come back down. They come down and generate higher lift on the wing. Now, pilot pre-flight item was to make sure you go out and push these things and make sure that they came down pretty evenly, because you didn't want it such that when you slowed down or pulling G's in a fight, that one slat would come out and the other one wouldn't, because that kind of disrupts things a little bit. There's also another little point here. If you overstress the airplane by like pulling 7 or 8 G's, you'll rip off the inboard half of each one of those slats. Don't ask me how I know. The weapons on the airplane had two 20mm internal guns. You can see one on their wing root there, and also they're on the airplane out here. And then there were external bomb racks. Initially there were 3 racks, and then started getting a little bit more horsepower in the engines. Why they put in 2 more racks, so they had 5 racks. What you're seeing right there is the two drop tanks, which you could configure the drop tanks on any one of those 3 stations. But the bomb there on the centerline station is, back in the 50s, that's how big the nuclear bombs were. And that is a nuclear bomb. One of the reasons it has such long landing gear is to clear that nuclear bomb. These are conventional bombs, and on those wing stations they would put what they called a multiple ejection rack. So you could put either 3 or 6 bombs on each wing station. Those are the fuses up there on the nose of the bombs. I'm proud of this picture. I just happened to be on a test flight in Vietnam, and we had taken a couple of our airplanes, and we wanted to do just to show that we could really stack some ordnance on there. And each airplane has 16 250-pound bombs on it. And I just happened to be available. We weren't supposed to be carrying cameras, and I was able to get this picture. Weapons delivery systems. The guns and rockets, they were forward firing. and you had a gun sight in there, and you put a little bit of depression into it, and it was usually a low angle, and you would get out there, and the guns you had 200 rounds. In Vietnam, we normally would, and like anything mechanical, keep using it. If you don't use it, it quits working. So we would usually try to fire the guns every mission, but only just a little bit. Because if your wingman went down, you wanted to be able to protect him a little. Then it had to have conventional bombs or nuclear bombs. And the delivery on those was dive bombing. This is before laser bombing and any of this computer stuff. This was just iron bombing, as we used to call it. And on the conventional bombs, you had a gun sight in there, and you'd be up about, say 10,000 feet, and you would set for each type of ordnance and the type of delivery you would do, there was depressions on the gun sight that you could see through, and it would be a little pipper. And it's actually, if your airplane's pointing to a point on the ground, you have a pipper that's going to be pointing where the bomb will fall. It's not going to go exactly where the airplane goes. And that was how you would walk it in onto the target and make sure you're at the right speed, at the right altitude, and hit the pickle button, and it should hit. But you had to take care of windage too. On the nuclear bombs, and this is something I didn't really know, until I got into this, was that I was even going to be in a nuclear situation, which never for real happened. But the training for that was too much fun to be legal. You'd go out, and we had some runs out in the desert, and you had to get down on the deck. Well, first of all, the typical nuclear delivery would be about an hour penetration at low level. When I say low level, I'm talking 200 feet, and we'd run those about 360 knots. And then when you get about 15, 20 miles from the target, and you've got on your navigation charts, and this is all just dead reckoning navigation and seeing ground stuff, you would get yourself on a lineup heading from a fixed point. And then you had a reference point somewhere along the line, and you accelerate to 500 knots, 200 feet, and then when you get to your fixed point that you knew, you would actually hit a pickle button, and it would start a timer, and then there was like a ILS needles in the attitude indicator, and when it got to the proper pull-up point, it would tell you, okay, start pulling up, and it would guide you through a 4G loop. And at the correct angle that we'd set in, why it would kick the bomb off, and it would keep going on that way and hit your target. Meanwhile, you're going over the top of the loop, and you roll out at the same altitude as what the bomb's set to go off, so you have the lowest profile, and you're trying to get out of there. By the way, I was in one place where we went in for the briefing, and I was told, folks, if this happens, don't be worrying about mom and the kids back home. They're smoking a hole. So this was really a tactical situation where you were trying to keep during the Cold War with the bad guys over there in that red country from moving in on Europe and what have you. Okay, emergency systems. Again, simple. The arrows that you see there are pointing to two mechanical handles. Each one of those handles goes to a cable, and it does different things. The one on the left, that's that one that unlocks the landing gear. That's the landing gear come down. The one right over the pilot's left knee is you pull that one, and everything on the bottom of on any of the stations out there comes off. Bomb racks, fuel tanks, bombs, everything. It just goes. And you do that if you've been hit, and especially if you're taking a hit in a wing tank where you're all of a sudden losing fuel. You want to get to where you're going pretty quick, because you just got that little tank right in back of you. And so you want to get rid of weight and drag. The other one over the other knee is the disconnect to the flight controls, like I talked about earlier. And then clear over there on the right, that's the one that puts the ram air turbine or the emergency generator out. Those were the basic things. By the way, the spin recovery on that airplane, to get it into a spin, you had to really force it in. I've never tried it, and it's very difficult. And my standard briefing was, if you ever got into a spin and you were, well, you're below 10,000 feet, it was mandatory ejection. If you were above 10,000 and you wanted to try to recover, pull the power to idle, get your hand off the control, and go wind the clock. Do nothing. Ejection seat in it. This was one of the first two seats, ejection seats the Navy bought that had rocket powered. Everything else before then was ballistic seats, we call them. They're basically a cannon shell that you sit on. And so when you initiated the ejection sequence, it'd blow the canopy and then hit that cannon shell, and you had to take all of it right at once. And so that's kind of hard on the old spine. So these rocket seats, they at least fire over maybe a 1 to 2 second period. So it takes the energy is applied to the body over that short time frame, but it's not instantaneous. So therefore, you know, it's more chances of not getting injured. I personally have seen 5 ejections. By the way, I mentioned it is 0-0 seat. That meant that you could be sitting on the deck with no airspeed and eject, and it sends you up 200 feet in the air. You get one coming down, and you would just swing down once, and your feet would touch the ground. The T-38 that Roy and I flew in, and Roy's flown a lot of those things, I think it was, 120 knots was, you had to be, if you were on the deck, you had to be going at least 120 knots for the seat to work. I've seen 5 ejections. 3 of them were right on the deck or right on the runway, all successful. The other 2 were right off the catapult on the ship, and that's 60 feet high as the deck height, so they weren't 100 feet out there. And all 5 of them, there were no problems at all. Here is on the ship I was on, a weekly or monthly magazine, and one of our guys had to eject on a bolter on a landing. This made the cover of the magazine. You can see the parachute up there, him coming down, and that white splash is where his airplane had hit the water. So as he went off the side of the deck, he initiated the ejection sequence, and helicopters were there to pick him up out of the water, no problem. Flight test program. Naturally, every airplane goes through this, and there's developments that come along with it. In this particular case, there was 3 here that I'll talk about. The first few tests, they got buffeting from the tail at high speeds. Well, they messed around with different ideas, and they came up with this inverted sugar scoop right over the tailpipe. And all the airplanes after that have that inverted sugar scoop. You can go out and see it on this one. Another thing they had was turbulence-induced rudder flutter. And flutter in a control surface is not a good thing. And so to fix that, they had this airplane has a smooth rudder. In the B model, this is an A model, in the B models and subsequent, they put these external ribs on there, and they straighten the airflow and reducing the vortices, and that took care of that. There was an erratic wing drop tendency in transonic flight regime, and they looked at various options on that, and they ended up putting in these vortex generators, they're called, and they really, along the leading edge there on the slat, and what they do is they actually add energy to the airflow and such that they keep it from separating. And that was their method of controlling that. Now, there was a friend Roy there pointed out to me during the test program, this was highlighted. The initial model of this thing, the A-4, only had one hydraulic system in it. And now, ever since then, the subsequent ones had 2 parallel hydraulic systems. And in this particular case, they were going up and they were just testing what kind of angles they should put on these vortex generators. And they were in a pretty high speed environment, and they had a hydraulic system failure with only one hydraulic system, and they had a erratic wing drop, and it went into a flutter situation, and it was pretty dramatic, and the airplane was totally out of control. And as I explained earlier, when you're on manual controls and you're a high speed, good luck. And unfortunately, he was not able to get out successfully. He did get out, but it was not successful. And so after that, they decided to put the tandem hydraulic systems in there. Did I get that right, Roy? Battle damage. Now, I was in South Vietnam. I never had to go over the north. And this is one of our airplanes. A friend of mine was flying this, and he was working a target down in the way south in the Delta. And he took a 50 caliber machine gun round through the wing. This is looking on the underside of the wing, just outside of the wheel well. And it put quite a hole in the wing, as you can see. And it went clear through the wing, and there's an equally sized hole on the top. And the pilot immediately blew off all of his stores, because by that time your drop tanks are empty anyway. And he headed for a short Army airfield that had a short field in there, about 4,000 feet, and landed there. He went out and looked at the damage and assessed it that there was no real structural component in there. That round just went right through. He called up the base and said, "Doug, send me down another drop tank and the starting equipment, the start cart and electrical, and a mechanic down here, and I think we can fly this thing out of here." And so I got a hold of the mechanic, and I told him what was described to me. And so he went and took his toolbox and a couple of rolls of duct tape. 500-mile-an-hour tape. Went down there, he looked at it and says, "Yep, that thing structurally is not in, no problems." And he taped it up, and we put another drop tank and filled it with gas. And the pilot was able to take off from the short field because he didn't have a lot of weight on it. And he pressurized the tank straight up into the feed tank and made it back to base. And that was taken, I took that picture when he got back to base. Now, look at this one. This is one of the Navy guys flying off the carriers over the north. This picture has been around a bit. He took a SAM hit over the north and was, again, dumped everything off the bottom and was trying to get feet wet out over the ocean. He didn't want to stay in the Hanoi Hilton. But you see the SAM blew off his rudder. You can see a couple of the panels in the fuselage blown open, and it put holes in the wing, and of course he immediately lost his fuel. And he's heading for the coast. And he thought, well, if he could get a tanker in there, he could plug in, and he could direct the fuel to that feed tank. And he lowered the landing gear after this was taken. The hook, when he had lost all the hydraulics, by the way, and so he was fighting this thing. And the hook will come down, you lose hydraulics. And he lowered the landing gear, and only the nose gear would come down. The SAM had taken out the mechanism for the main gear, so that made any attempted landing just wasn't there on the ship. And so when he got feet wet out there, he ejected, They picked him up, and he was on a flight schedule the next day. I like this sketch. This is their guy, R.G. Smith, that's done a lot of sketches for A-4s. And this is called, this one, Spotted on a Waste Cat on an aircraft carrier. Now you can see a lot of things here, and I'll briefly go through it. You see the center line the center line station has 6 bombs on it, and then the 2 stations with the fuel tanks on it, and the 2 outboard stations, they have a pod of forward firing, those are 5-inch rockets, and those are pretty potent. You can see the fella there with a bar. Keep the weight down. There was no nose wheel steering in these things. You had to steer it with just differential braking. But when that airplane is fully loaded with bombs and fuel, you had you'd have to put so much power on it. You would be blasting everything away to try to get it to turn. On the flight deck, they always used to do any turning. They had a guy from the flight deck come in there and put this Tilly bar into the nose wheel, and he would actually steer it for you out there. So that's what he's doing. He's steering it. You see the fellow out there with his hands up? He was a yellow shirt flight director. And on a carrier, you don't do anything. You don't go anywhere unless you're looking at a flight director in the eyes and he's telling you to come forward, go that way, and then he'll pass you off to another flight director. He's directing right now to this airplane up onto the catapult, and he's actually told him, okay, stop. This is a pretty good diagram of how the A-4 was hooked up to the catapult. You can go out there and look on the airplane, but you see up in the wheel well there is 2 hooks, one on either wheel well. And then there's a cable that's got 2 eyes on it that they stretch between the hooks, those 2 hooks, and it goes down to a shuttle on the deck. That shuttle is hooked to a big steam piston below deck. And then they hook that bridle up to that shuttle, and that is when they fire it, that shuttle goes forward, and that is that's how the airplane is. It pulls it through with that bridle, and then you fly out of the bridle because you see the hooks are facing backwards. There was a catapult holdback, and this is I thought pretty interesting. There's a cable that's hooked to the deck, and when you taxied in to the up on the cat, there's a little receptacle, and you can see it where that red arrow is. There's one on the airplane, and then at the end of that cable, there's another receptacle. It's like a little two little cups, and they had a little barbell that they would put in there, a steel barbell the cups would hold the big ends of this barbell, and there was a accurately machined tube between there that was designed to withstand the entire thrust of the airplane's engine when you're up on the cat. And a jet engine, they could take maybe 10 seconds to get from idle up to full power, and you can't hold it on the brakes at full power. So the idea here is before they fired the cat, you wanted the engine up to full power. And so they have this holdback. Now that thing is designed just for that engine thrust, and as soon as the cat is fired, it breaks it, and then off you go. It's interesting, when I went through this training program and how I got aboard ship, there was a 6-month program after I got my Air Force wings to get to Vietnam. And when I went through the 3 months and got my Navy wings and reported into a operational squadron on the East Coast. And they told me, about a month into that, I was 6 weeks from going to Vietnam. Skipper came in one day and said, okay, this is classified. The Navy was transitioning from A4s to A7s, and they came up short of an A4 squadron to go on a Mediterranean cruise on a carrier. And our squadron has been elected. Now, the Marine Corps hadn't put a squadron aboard ship since the start of the Vietnam conflict. So going aboard ship was not even on the radar for us. And then there was some of us that went through training in the Air Force, and the Navy training, they go out and they hit the boat. And I hadn't even seen a boat. And I said, what do we do here? And they said, don't worry, when we do the workup, they'll teach this with the whole squadron. You'll learn how to land. And we did. And came time for the workups. It was 3 weeks of doing nothing but flying in a traffic pattern. In the morning, at night, the ship had sent a LSO down, landing signals officer down, and we did practice landings. And then it was time to go aboard ship. I was saying, what about this catapult shot? And there was no way they trained you for that. And one of my buddies had been through the Navy program. He said, don't worry, Doug, it's better than sex. And I thought, oh, wait a minute, I was a bachelor down in South Carolina, and I'm looking for trying to find women. I said, no, you don't have this right. Well, at any rate, the first cat shot, he was right. That is a A-4 taxiing onto the cat. Now you'll see the flight director there, and then now he came to stop, and that's the cat officer telling him to run the engine up. And if you notice there, there's a guy on a panel off to the side, and he had his hands in the air. Once you're hooked up to the cat, and they put a little tension and a steam tension in there to tighten everything up, why, if somebody pushes a button, you're going flying. I don't care if you got your feet on the brakes, the throttle at idle. If they fire that cat, you're going. And so that was very, very tightly controlled. And when the cat officer would tell you to, wind it up, you would run it up to full power, and then check your engines out. And then when you were satisfied with your airplane, you would salute the cat officer. Well, when you're out there on cyclic operations, you had to be very careful, because if your hand went above the canopy rail, you're going flying. It was pretty exciting. It really was. The arrested landings. You don't land an airplane on an aircraft carrier. You fly it onto the deck. You get to, there's 3 things that the pilot is looking at. Line up with the center line on the landing area. Angle of attack of the airplane, which is the indicator in the airplane. You're at the optimum angle of attack for your particular weight. And you're flying the glide slope. And you hear this term in the movies, the ball. Well, the ball is the glide slope. I'll show you that picture of how that works. And those are the only 3 things you look at. You don't look at the deck. You don't look at anything else. And you keep on flying and flying and flying. And you can feel it when it hits the deck. And you're just a constant rate of descent, and you hit the deck, and the landing gear is designed to absorb that. And then you immediately go to full power and put your speed brakes in. And you assume that you're not going to catch the wire, and you're at flying speed at that time. The deck has stopped your vertical descent, so you're flying airspeed. You get to the end of the deck, take off and fly, come back around and try it again another day. And that is called a bolter. If the hook catches, why, believe me, you know it. And one of the checklist items was to make sure your harnesses are locked, because if you don't have your harnesses locked when you make an arrested landing, you will eat the gun sight. This is the mirror, or the optical landing system, or the ball. And there's the green datum lights out there, and then you can see the 5 lenses, they're Fresnel lenses. And the light in the middle one, the idea is to line up that light with the datum lights. As you were high, there's actually 5 different glide slopes going out into space there. And if you were on the middle one, you're where you should be. By the way, the target wire for the middle glide slope when you're flying the ball correctly is the third wire. So, and there's 4 wires. So if you catch a 1 wire, you're where you shouldn't be because you're pretty darn low. And in fact, that bottom lens is red. And that tells you, you know, guy, you know, you may have USS Independence stamped on your head here if you're not careful. When you come into the break, you're at 500 feet. They don't want any descending turns. So these guys are in the break at 500 feet above the water. And then that's where they take their separation on downwind. And then on final, you see the ball is off to the left. And you fly it on. You also have the speed brakes out, just so you have a higher power setting. And then you put the brakes, you close the speed brakes and go to full power. And there's a guy that runs, these 19-year-old kids on the flight deck, I take my hat off to them. Sometimes that wire gets stuck to the hook. He's trying to knock it off and it won't, so they'll wring the wire back and then he'll hit the brakes and then it'll come out of it. Now that's a bolter there. He missed the wire and no big deal. Come back around and try it again. A couple of things on carrier operations. We had zip lip operations where the ship would shut down all of its navigation equipment. You weren't allowed to do any radio transmissions, even with the airplanes were 100 miles with the carrier. You were prohibited from making any radio transmissions. So they would do a launch and recovery, and there were specified times, such as when you have a clear deck, that you had to come in and make sure you met your landing time, but you couldn't be talking. So you did the whole recovery, launch and recovery, without any radio transmissions at all. One time, I had an interesting one. I was Dark 30 launch one morning, and we were out, I was 2 of us, and I was a wingman, junior lieutenant, and so and you will look good around the ship. So you have to be in tight formation. And I'm sitting there, I'm looking out the side of the airplane, keeping my position, flying on this guy. Well, he was flat-hatting out there a couple 100 feet over the waves. And it was a real windy morning, and there was salt spray blowing, and I didn't really realize it. And when we came around, and I'm just looking out the side window all the time, and then when we did the break, I'm still looking out the side window on the aircraft carrier on downwind, and then I started my turn to final. And when I rolled into the final turn, the sun was just coming up, and the ship was headed right into the sun. And there was a salt spray on that flat windscreen up there, and I couldn't see a thing. And I keyed the mic and said, "Negative ball, salt spray." The landing signals officer, "Roger, keep it coming. You're a little left, correct. Okay, you're a little high." And he just talked me right in, and I got a 3-wire. Another time, I was down in the ready room, and the ship was alongside an oiler. And and by the way, I didn't mention this, but you need 30 knots of wind going over the deck for landing and launches. And if they don't have enough wind, they always turn into the wind, and then they'll put enough steam on the boilers front of boilers to get that 30 knots of wind. That's why you always see these guys are working on the flight deck leaning into the wind. We were sailing next to this tanker, taking on bunker fuel for the boat and jet fuel for the planes with hoses connected there. And so the whole effort is for the boat drivers is to keep the 2 boats right steaming along together. And it didn't matter, they don't pay attention to the wind in that. It was a sea state and what have you, they're more interested in. And I was in the ready room, and I got their phone rang, and the duty officer talked to somebody, and he looked up at me and he said, "Suit up. There's an airplane spotted on the CAT up there. Go man it." You know, we're not even flight ops, and what's all this about? So I go up there, and sure enough, they got a A-4 spotted on a catapult. And I did a quick pre-flight and got in, and I said, well, what's this all about? Pretty soon the operations officer came out and said, what's happening, what's going on is there's a Russian bomber circling around out there. And the F-4s cannot take off, or they can't launch the F-4s in a no-wind condition. And so the A-4 is light enough that if they have to, while we're cruising along with this boiler, this tanker, they'll launch you. Oh, okay, this sounds interesting. So I'm sitting there just kind of waiting, and the CAT officer walks by, and he looks up at me and kind of smiles, and he takes out a handkerchief and he drops it, and it went straight down. No wind. And then he turned and he kicked his leg out, and he, as if indicating to me, you're going to get a real kick in the butt. And I never did get it. The guy flew away. But another time, I had briefed a flight. It was with the F-4 squadron. It was 2 and 2. We were going to go out and do some air combat maneuvering, dissimilar aircraft. And I was kind of keen on this. May learn something from these F-4 guys. And so we had briefed the flight. And then we went up to man the aircraft, and we had a rendezvous point where we were going to meet up. And I was shot off the CAT, and no sooner was I shot off the CAT, I was told to switch to one of the tactical control frequencies of the ship. And I switched frequencies, and they said, we got an inbound bogey, and here's your vector. And they vectored me in to this bomber. It's a Russian-built bomber flown by the Egyptian Air Force, and the Russians and Egyptians were pretty tight during those days. And this is at 500 feet above the water. And I joined up on him, and I flew along with him for almost an hour. And we never got above 500 feet, and he was maneuvering around out there. And I kind of waved at the guys in the back turret there, and eventually they never did try to overfly the ship. They flew around it, but they didn't try to overfly. But that was kind of an exciting one for me. One of the reconnaissance airplanes, Vigilantes, flew over and took this picture. Well, now I did my med cruise, went back, and I had a year in the States, and then I had to do an overseas tour, another one. And by that time, the Marine Corps had pulled, this was like 72, and the Marine Corps had completely pulled out of Vietnam, and we were all going up to Japan. So I got orders to go up to Japan, and I checked into a squadron there, and they went down on a deployment down in Okinawa. And we were, because of better weather down there, and we were doing practice bombing and what have you. And went to work one morning. A duty officer said, go back, pack your bags, be back in an hour. I did that, came back, and they said, all right, leave, put your name on your footlocker, put your name on your motorcycle. There's your airplane, there's your flight plan. That night I was in Vietnam. That was pretty short notice. This is a picture of our flight line down in Vietnam, 2 A-4s, and they kept them in these revetments, you can see, because we got a lot of rocket attacks, and they hurt airplanes. And so for starting up, where we would pull them out, and then we would go do our startup and everything, and then from there the guy'd come along with a tilly bar. When they were full of bombs, you still needed the tilly bar, and we'd turn out and taxi out. And this was a picture I took of one of our flights going out. You can see the bombs there on the center line rack, and he actually has one bomb on each of his outboard wing stations. So he has a total of 8 500-pound bombs on there. Before we get into questions, I got one war story I'll tell. and I could tell you a lot of them. But I was working, assigned a target down in, or assigned to go to, all the bombing was done under the control of a forward air controller. Was there flying O1s, O2s, the Skymasters, or some of them were flying OV-10s, depending on where you were. And this was Air Force pilots, and they would be in contact with the ground commanders, and then they would be in contact with the Direct Air Support Center, and they would call in assets as needed to support the ground troops. So you never did anything without a forward air controller. So I was given a forward air controller's call sign, his radio frequency, and his position. And I flew down to the Delta. I had a wingman with me. I got overhead the target, and there was just tremendous radio chatter between the forward air controller and a flight of F-4s working the target. And so I was just holding high above these guys watching it. And I could see that the F-4s were taking 50 caliber fire. And then I saw where the forward air controller was taking 50 caliber fire. Now, that's dumb. Shooting at a forward air controller is not the best thing to do, because those guys can one click of one radio transmission, and they can get anything they want. Well, at any rate, so I couldn't get a word in edgewise to say, hey, you're taking fire. So the F-4s finished, and they pulled off, and everything pulled off a little bit. And he gave them their battle damage assessment. And then, okay, my turn. I checked in. He gave me a target briefing. Mainly, you want to know where the friendlies are versus where the bad guys are. And he controls your run-in heady, and he's giving me all this briefing. And he said the last flight in here, they were taking ground fire. And I said, yeah, and so were you. And this forward air controller says, oh, really? I detest people that shoot at me. Where did you say that fire was coming from? So I described the area where I saw the fire coming from, and he swung the airplane around, and he scouted it out, and because he would want to make sure there was no friendlies there. And he said, you are cleared in hot where you saw the fire come. And that guy had 16 500-pound bombs on his head there. So that's not a good idea. Okay, I could go on with war stories, but I won't. I see I'm right out of time. And I'll be glad to take any questions. What was your first night? Question was, what was my first night carrier landing like? The answer is scary as hell. Once you're out there during day VFR operations, you just as soon work off the boat than you would land base. You really are. You're used to it, and you land on it. You got all the emergency equipment there. It's really good. Night carrier operations, as far as I'm concerned, is insane. And I mean, from the cat shot on, the cat shot, you're sitting there, and it's kind of disoriented at best. And then you're off the bow, and it's black. And you're 60 feet off the deck, and there's no horizon out there, and and your eyeballs are coming uncaged, and then you gotta fly your mission. Then you come back, and they do straight-in approaches there, and they're pretty good about giving you a carrier-controlled approach. It's like a GCA, but when you look up, you can't see nothing but this ball, and there's lights for the lineup. It's scary. I didn't like it. Does that answer your question? Any other questions?
You didn't mention the humpback.
The question is, I didn't mention a humpback, and that's a good observance. I probably should have put it in there. When A-4s were first going over North Vietnam off the carriers, and it was, again, iron bombing, and they had to do dive bombing to get in there and hit the target. These Russian SAMs, the SA-2s, there was quite a few of those in there, and they're radar guided. And they took a pretty good toll. They developed electric countermeasures gear, and I could go into how they work. There's a couple different systems. One, it would tell you you're being scanned by radar, and another would actually pick up the radar signal, and then it would have a way of jamming, or not really jamming, but it would throw it off such that your target was, it would think that ideally the missile would go behind you. So, back in those days, this is before solid states. In fact, some of the original A-4s had vacuum tubes in their radio and their navigation equipment. So very heavy black boxes in there. I mean, they were heavy. And there was no room to put them in the airplane, so they put the hump on there. And they actually retrofitted a few models of the A-4 with that hump and put that gear in there. And that was as a result of the surface-to-air missiles in North Vietnam. Anyone else have a question? Oh, wow.
Did I understand?
Well, the question was, what was the emergency power unit? The emergency power unit was simply a generator that had a turbine on the front of it, and so you drop that out into the airstream, and they had variable blades on there to control the RPM of the generator, and that would just enough to power essential systems, electrical systems in the airplane. That was all it was just a generator driven by the wind. The question was, how many combat tours did I fly? Or combat sorties? That was the question. I flew 220 some. We flew, and again, this was all the South Vietnam 3 Corps, 4 Corps, and that place where we weren't supposed to be, Cambodia. And it was all close air support work or known enemy locations. And we flew normally two sorties a day, 7 days a week. And we didn't fly Christmas and New Year's. Other questions?
Yeah.
Right here.
What field were you?
The question was, what field did I fly out of when I was in Vietnam? I flew out of an Air Force base that was about 15 miles north of Saigon called Ben Hoa, and I really felt fortunate because the Marines didn't usually get as nice accommodations as the Air Force did. The question was, when you manned the airplane, how long did it take for it to eventually, the air conditioning system to cool you down? Well, for one thing, until you can get the engine started, there's no cool down at all. And then once you get the engine started, you could turn the air conditioning on, and it would start cooling things down. You didn't close the canopy until you were. Normally, we didn't even close the canopy until we got out to the end of the runway. Aboard ship, you closed it right away. But it didn't take too long. It's a pretty efficient air conditioning system in there. The question was, when they did the bomber intercept, why did they send me? Actually, they sent an F-4 flight up there, too. It was just, who was off the cat first? And so the F-4 and I got there about the same time. And he went on the left wing, I went on the right wing. And when the reconnaissance plane came over to take the picture, he, for whatever reason, took a picture of just me. I think it was just to let them know that we're there. There wasn't, the only thing, I didn't have any armament with me at the time. I couldn't have done anything. The F-4, it was the airplane I was supposed to be in the fight with, ACM, and I don't know if, I think he did have some sidewinders. About the only thing I could have done was flown up in front of the guy and dumped fuel and flamed out his engine. And such that you weren't getting the airplane asymmetrically loaded. I think that was your question. Very good question. Normally, you could set it up in the cockpit to release the bombs in any kind of way you wanted. You could set it up so you would ripple them all off in one pass at a so many microseconds interval, or you could set it up and drop in pairs. The idea was that ideally you would make one pass and get out of there. But normally on these close air support missions, why I didn't, dropping single bombs is just too much exposure on the target, so I usually dropped in pairs. And so I would start with the outboard sections and I'd drop both those bombs at once. And I could configure it, and then you would, so I would try to select my ordnance just for that very reason that you're talking about, such you don't get everything on one side of the airplane. So you had the option of selecting that. Sir, the question was the original airplanes configured for the nuclear assignment? That was one of the primary missions, was that it would be nuclear qualified, nuclear capable. Okay, sir. Good question. The question is, and I read the article in the Wall Street Journal recently, that Navy, Air Force, and Marine pilots aren't getting enough flight time because of this reduced funding available. And the article, the thrust of the article is, you know, this is hurting pilot proficiency. And I think, what was it they said? They were looking at trying to get 200 hours a year. Was probably a good trade-off for being proficient. I would agree with that. Fortunately, unfortunately, however you want to look at it, during the Vietnam era, we had a little bit of extra money was being funded for aviation, and I ended up with just a short time, 4 years I was flying the A-4, I had 1,000 hours in it. I will be willing to hang around. I've been given a signal here that I've got to wrap it up, and I'll do that. But please feel free to come see me after we wrap up if you have any more questions. And thank you for your time.